Hello everyone and welcome again to my YouTube channel. Okay, so our topic for this video is to design a singly reinforced beam in three ways. Okay, so without any further ado, let's now start to design this problem. Okay, so a simply supported beam with 4 meters span and 30 mm wide has an effective depth of 500 mm. Determine the required numbers of 20 mm diameter bar in tension zone to support dead load of 22.75 kN per meter and live load of 34.5 kN per meter. Use Fy is equal to 414 and F prime C is equal to 28 megapascal. Okay, so kung ito yung section natin, ito yung required na hinahanap natin, area of the steel, and we will draw the strain and stress diagram. Okay, so kung ito na yung strain and stress diagram natin, and we are required to calculate the numbers of 20 mm rebar at the tension zone. Okay, so since main bar ang hinahanap natin sa beam, which is in the tension side, okay, and ang main bar ng beam is intended to support moment load. Okay, so yun, so kakailanganin natin ang moment produced by this uniform load. Okay, so before natin ma-compute yun, so from NCP, kailangan natin i-factor ang load. Okay, so the uniform load is multiplied by 1.2 multiplied by dead load plus 1.6 multiplied by live load. Okay, so ito na yung magiging factored uniform load natin. Okay, and then substituting will give us the value 82.5 kilonewton per meter. Okay, so from dito sa 82.5 kilonewton per meter, kailangan nating makuha yung maximum moment na kayang i-produce ng load na yan. Okay, since simply supported beam siya, ang maximum moment niya located at mid-span, and that is equal to the uniform load multiplied by L squared over 8, and L is equal to 4, and will give us factored moment is equal to 165 kilonewton meter. Okay, so kung meron na tayong moment, we are now ready to solve the area of steel. Okay, so ano ba ang formula to solve the area of steel? Okay, this is equal to rho of times the BD. Okay, rho is the ratio of the area of steel divided by the area of this one, ang effective depth and the beam width. Okay, so paano ba, meron tayong B, which is the beam width and the effective depth. So ang kulang natin is rho. Okay, so paano ba natin mako-compute ang rho? Okay, one way to compute the rho is by this one, by the table. Okay, so nakikita to sa likod ng ating mga textbook, ang mga design. Okay, so rho, so makikita natin dito rho and R, and R is the resistance coefficient. Okay, so itong table na to is in PSI unit. Okay, so pag meron tayong R, makakakuha na tayo agad ng rho. Okay, so paano ba tayo? So kailangan natin makakuha ng R muna, or the resistance coefficient. So ano ba ang formula to get the R? Okay, so R is equal to mu over P BD squared. Okay, so meron na tayong factor load or the mu. Okay, and P is equal to 0.9 since ang consideration natin to design is in tension side. Okay, okay, tension controlled siya. Okay, and B and D is meron tayo. Okay, so yan yung one way to solve the area of steel. Okay, so second, what if wala tayong table na ganito, hindi to given, okay, or wala tayong copy nito, say so board exam hindi siya given, how can we solve the rho? Okay, so another way to solve the rho is the by this formula 1 over m and open parenthesis 1 less square root of 1 less 2mr over fy. Okay, then close parenthesis. Okay, so meron tayong r. Given ang r dito, meron fy. Ang hindi given sa atin is m. So ano ba ang formula to solve the m? Okay, so m is equal to fy over 0.85 of f prime c, which is given sa atin lahat. To fy and f prime c is given sa atin. Okay? So, pag meron tayong m, meron tayong r, we can now solve the row. And pag na-solve ang row, makukuha na agad natin ang area of steel. Okay? So, meron tayo nito, masosolve na natin ang r. Ano ang next step is to compare it dito. Okay, so as per ACI code, meron siyang minimum requirement. Okay? So itong value na to is in PSI unit din. Okay? So next, kung above minimum siya, we need to compare also if below the maximum value. So ito yung maximum natin ng row for the singly reinforced beam. Okay? We will show you mamaya kung paano nakuha itong formula na to. Okay? And then, kung within the range na siya, yung na-solve nating row is within the range above minimum and below maximum. So, pwede na siyang gamitin to compute the area of steel since conforming siya sa ating ACI code. Okay. Now, since meron na tayo nito, we will now solve the value of R. Okay? R is equal to mu over PBD square. Let's substitute. Okay, substitute mu or the factor load is 165 times 10 raised to 6 over P is 0.9, B is 300 times D is 500 squared and will give us value of R is equal to 2.44 megapascal. Okay? So, sabi natin kanina, itong table natin is in PSI. Convert muna natin siya into PSI. Okay? So, 300, ang R natin is 354.47 PSI. Okay? And that is equivalent dito. Okay? So, in between siya, since 354 siya, in between siya ng 350 to 355. And the raw value is in between 0.0069 and 0.007. Okay? So, we can use this to solve the A, okay? But we will try to solve it using this law. Okay? Now, let's go to solve the M. 414 over 0.85 times 28. Galing dito. Okay? And then, will give us value of M is equal to 17.395. Okay, and then let's solve it. Let's solve the row using this formula. Okay, substitute natin ang M and R. Will give us row is equal to 0.00624. Okay, question, bakit mas maliit yung lumabas sa atin dito sa row? Okay, since ang sabi niya rito, within the range siya ng 0.0069 to 0.007, eh ang lumabas na atin 0.00624. Okay, so it is simply because that ang Fy kasi natin dito is 414 and it is not exactly equal sa 60 megapascal. Okay, so 414 natin kasi ang exact value ng 2 PSI is 60,045.60 mega PSI. Okay? And then, ang F prime C naman natin, dito kasi 4,000, ang F prime C natin na 28 megapascal is equal to 4,061.06. Okay? So, may konting difference siya. Okay? Now, so, but you can also solve using the table in metric unit. Okay? Now, meron na tayong row and we will now compare it kung above ba siya into minimum and below maximum. Okay. Now, let's go to the minimum first. Okay, so yung minimum natin is 1.4 over Fy. Okay, so kung mapapansin nyo, walang 1.4 over Fy dito, since ito nga is in PSI. Okay, kung i-convert natin itong letter B, this is equivalent to 1.4 over Fy. Okay, P ang pinili natin kasi nung sinubstitute natin, mas malaki ang lumalabas dito sa letter B. Mas malaki ang lumalabas dito, and then dito is mas maliit. Okay, so ito yung ginamit natin, 1.4 over Fy, and substitute Fy as 414 will give us a minimum of 0.0033. Okay, and then next is the raw maximum. This one, 38 multiply it by 0.85 F prime C beta 1 over Fy. Okay, saan ba galing to? Bakit nasabing to maximum? Okay, explain natin. Okay, so from this formula, ASFy is equal to 0.85 F prime C AB, or galing dito, T is equal to C. Okay, and then i-compute natin ang value ng C. Okay, ang C natin by ratio and proportion, C is to 0.003. Okay, and D, which is this one, is to 0.003 plus the strain of the steel, which is ang consideration nga natin is tension control. Okay, so tension control it should be 0.005. Okay, so kung kinonsider natin siyang 0.00, bakit maximum? Okay, so ito, okay, kung dumami pa ang steel natin, which is dito, for example, ito na yung design natin. Pag dumami pa to, pag dinamihan pa natin ang area ng steel, lalaki ang value ng T, since ASFy. Okay, so agree tayo. Pag lumaki ang value ng T, kailangan din lumaki ng value ng C, since they are equal. Okay, so pag lumaki ang value ng C, lalaki ang value ng A. Okay, so pag lalaki ang value ng A, lalaki ang value ng C. And at the same time, bababa ang neutral axis natin. Okay, like this one. Pag bumaba ang neutral axis natin, liliit ang strain natin, like this one. Okay, so ito, same pa rin tayo ng 0.003. But bumaba ang neutral axis natin. Itong dating 0.005 na consideration natin is liliit siya ngayon. Okay, so yun yung effect niya kung dinamihan natin ng steel. Kaya nililimit lang tayo dito. Okay, so 0.005. So I think nagets naman natin. And then we will, since dito naka-A siya, kukunin natin tong value ng nito, sa-substitute natin tong C para magawang A, and then A is equal to beta 1 C. Okay, beta 1 natin is 0.85 since 28 megapascal lang F prime C natin. Okay, now let's simplify. AS over BD is equal to 38.85 of F prime C beta 1 over Fy, and that is now the raw maximums. Okay, AS over BD is raw. Okay, so I think hopefully na naintindihan natin kung saan nanggaling ang raw max natin. Okay, and now pwede na nating ituloy ito. So raw max, and then we'll substitute values dito sa F prime C, beta 1 and Fy, and will give us the value of 0.0183 na maximum. So kung napapansin natin, ang raw na nasolve natin kanina is 0.0624. Okay, and then above minimum siya, and also below maximum. It means nasa range siya ng minimum and maximum. Okay, gumawa din tayo ng table to simplify. Table lang from the standard na F prime C and Fy natin. So ang F prime C natin is 28, that is roughly equal to 4,000 nga. Okay, and then ang Fy natin is 414, and that is roughly equal to 6,000. So ang raw minimum niya is 0.0033 and raw maximum niya is 0.0018. So ito na yon. Okay, this one. this one. The raw minimum 0.0033 and 0.0183 ang maximum. Okay, so pasok yung nakuha nating value ng raw, and then compute na natin ang value ng steel. Okay, using the formula rho BD, and meron na tayong lahat yan. Substitute will give us 936.52 mm squared. Okay, and then kunin natin numbers ng rebar using 20 mm diameter bar, and will give us a value of 2.98, or that is equal to 3 pieces. Okay, now ito na yung pangalawang method. We can now use the last method. Say, nakalimutan natin tong formula na to. Okay, say, una, nakalimutan natin to, or hindi given, and then pangalawa, what if nakalimutan natin tong formula na to? Okay, so since we are designing a beam, the design moment capacity should be greater than or equal to the factored moment mu. Okay, so PMN is greater than or equal to mu. Pero ano ba ang PMN natin? So ang PMN natin is using this equivalent stress diagram, that is equal to ASFY multiplied by D less A over 2. Okay? So, take a moment at this one, at C, and then makukuha natin to. ASFY, and multiply natin sa moment arm na to. Okay? Yan yung D less A over 2. Okay? And then, next, wala tayong value ng A. Okay? And kukunin natin yon, same pa rin, dyan pa rin. Okay? And ASFY, makuha natin ang value ng A, and A is equal to ASFY over 0.85 of F prime C B. Okay? Meron tayong FY, meron tayong D, wala tayong A, pero substitutean natin ito. Meron tayong FY, meron tayong F prime C and B. So, ang unknown na lang dito is the AS, which is yun yung hinahanap natin. Since ang MU naman, the factored moment is equal to 165 kN/m. Okay, so substitute natin ang A dito, and will give us this one. Okay, ASFY multiplied by D less ASFY over 0.85 of F prime C B times 2 galing dito. So, ang pinaka-unknown na lang natin dito is the AS. Okay, let's simplify. Will give us this one. 1.7 is from the 0.85 times 2. Okay? So, substitute natin yung mga values na meron tayo. Ang unknown na lang is the AS. Okay? The area of the steel. And P is 0.9, since, as mentioned nga kanina, nagdi-design should be in tension control. Okay? And kinonsider natin kanina dito is tension control. Okay? So, now, isang unknown, we can solve the value of the area of steel is equal to 936.52 mm squared, which is equal siya dito. Okay? So, bakit nag-equal siya? Hindi naman natin siya ginamitan ng R and M, including the rho. Okay? It is simply because that itong formula na to na rho, to get the rho using R and M is galing yan dito sa formula na to. Okay? Then, pakita natin kung paano nangyari yun. So, ito, from this formula, okay, that is equal to dyan, parehas lang. Okay? And then, what if we will multiply it by 1 over BD square? Okay, so multiply tayo both end. So that is still equal. Since anong minultiply natin sa kabila, siya rin minultiply natin sa kabila. Okay, so simplify natin will give us this one. So at this side, nakabuo tayo ng AS over DV. Okay, and we will substitute natin yan as rho. Okay, so meron din dito AS over BD, this one. That is still a rho. And FY over 0.85 of F prime C, substitute natin yan as M. And then MU over PBD squared, substitute natin as R. Okay? And then, magiging ganito siya. Okay? And then, what if mag-multiply ulit tayo both side by negative 2 over m multiplied by Fy. Okay? So, both side ulit, nag-multiply tayo. So, it is still the same. Walang pagbabago yan. Okay? So, magkakaroon tayo ng rho squared is equal to, or 2 rho over m. That is equal to 2r over m Fy. Okay? So, kailangan natin makuha ang value ng rho. So, gagawin natin is, gagawin natin perfect square. Okay, let's add both side by 1 over m squared. Okay, and simplify natin. Makakuha tayo ng ganito. Okay, since perfect square na to, it is the rho less 1 over m. Okay, and then simplifying again will give us rho is equal to 1 over m multiplied by 1 less square root of 1 less 2mr over Fy, and that is now still the same dito. Okay? So, na-prove na natin na ito is galing siya dito sa formula na to. Okay? So, now, meron na tayong na-design na 3 pieces na 20 mm rebar nga. Okay? And then, we will try to analyze. Say, hindi natin alam ang moment capacity niya. We will analyze this beam with this dimension na meron siyang 3 pieces na 20 mm diameter at tension zone. Okay? And then, titignan natin kung above the requirement ba siya or above the factor load of the 165 kN meter. Okay? So, ito, papakita natin yung analyzation natin. Okay, so ito na yung analyzation natin using the same dimension, 300 mm and 500 mm ang effective depth. Okay, using 3 na 20 mm diameter rebar. Okay, yan ginamit natin siya dito. Okay, and nag-come up tayo na the value of the PMN is equal to 165.99 kN meter, and that is greater than sa factor moment natin na 165 kN meter. Okay? So, yung design natin is considered as safe. Okay? So, I think that's all for this topic, and if you have questions, clarifications, recommendations, you can just comment it below and babasahin natin yon for us to consider. Okay? Feel free also to like, subscribe, and share. Okay? So, thank you and God bless everyone.